Distance, rate, and time. So these problems. So boat travels for 5 hours with a current of 10 miles per hour and then returns the same distance against the current in 7 hours. So the current, we'll say, is going this way, right? You have a boat, so we can visualize this. We have a boat, this little person, and he's going this way. When he goes this way on this trip, this is taking him 5 hours. And the current is 10 miles per hour. So this is pushing him 10 miles per hour extra on top of what he's traveling. So going the opposite way, so let's draw another picture. When he is going the opposite way, it says, so the current is still pushing this way, but he's traveling the same distance backwards on his, so he's traveling the same distance against the current, and it took him 7 hours to travel against the current. So he's going this way, and it took him 7 hours. What is the boat speed in calm water? So I already added the rate times time equals distance. We always know that on these problems, a chart helps the most. So I'm going to have to answer what the rate is, what the time is, what the distance is. And we're keeping the same distance, and I'm going one direction, then going the other. So this would be a round trip type of problem, which means that once I find these distances here and here, all I need to do is set this equal to this and solve. So my rate when I'm going with the current, so I'm going to put with right here, and then my rate when I'm going against the current. So I'm going to use this as my two different directions. So with the current and against the current. So with the current, I know that I'm getting pushed an extra 10 miles per hour. So plus 10 miles per hour. Against the current, I am not sure what I'm getting, so I'm just going to put R. So I'm going to keep this as R and R plus 10. So my time here is that my time is given here is that with the current I'm going 5 hours. Against the current I'm going 7 hours. So when I multiply this across, before I do, it helps to keep this in parentheses when you have more than one term. So this becomes 5 times R plus 10 and 7R. And we said if I set this equal to each other, then I'll know my rate. So 5R, 5 times R plus 10 is equal to 7R. And this is going to be 5 times R is 5R plus 50 is equal to 7R. So minus the 2R, or minus the 7R, minus the 7R. Wait a second. Let me move this a little bit so I have some room. So, just a second. I'm going to lasso this and move it over here so we have more room to work. That's better. Okay, so I'm going to move the R's to one side. It's easier if I move the 5. So minus 5R minus 5R. And this is 50 is equal to 2R. Divide by 2 both sides. And R is now equal to 25. So R is 25, but that is not my answer. So I need to know what is the boat speed in calm water. Okay, so once I have this 25 equals R, I'm going to have to take this and plug it back in. So here would be 25 plus 10. So my answer would be 35 here for how fast he's going with the current. Against the current, he would be going 25. So right in between these 2 miles per hour would be his speed when there is no current. So no current, would be 30. That's right in between 25 and 35. So 30 miles per hour would be your answer. Okay, for the next problem, number 30, it's still asking about 29. So how far did the boat travel one way? So I'm going to take this 25 right here and pick either one. It doesn't matter because we had the distances set equal to each other. So you travel the same distance. So it'd be easier to just say, what's 25 times 7? And I got this from 7r, which is equal to 7 times 25 after I substituted in. So this would be 35, that's 14, 17, would be 175. And I looked for my unit, and it's talking about miles. So 175 miles is how far the boat traveled.